Okay, so in this video, we're going to talk about while loops. So, in daily life, right, uh, you might continue to do something, or you might repeatedly do something until some condition is satisfied. Uh, or you could think of it the other way, which is um, while the condition is satisfied, you continue to do something. So let me give a few examples, right? Like, for example, when while you're hungry, you just keep eating, right? Like, so what does that mean? Well, we can kind of see it like this. So while hungry, so this is your condition, right? Your condition is that you're hungry, and if if you're hungry, right? If this is true, then you keep eating, right? Something like that. Okay. Um, or, you know, let's say you are trying to get your steps in today, right? You don't have enough steps, so maybe you want to walk, but you don't have enough steps. And so while not enough steps is true, which means while you don't have your steps in today enough, let's say you want to, set your goal of taking 6,000 steps per day, um, and you're not there, maybe you're like 3,000, then not enough steps is true. And so you walk, right? So while you don't have enough steps in, you walk. You continue to walk, for example, right? So these are some of the examples that could be sort of seen in real life. Now, in terms of the coding world, something that would be, I think, more familiar to most of you is in games. Usually you could think of it as, while the game is not over, the game continues to run, right? Like if the game continues running and you keep playing, right? So what does that look like? Well, we can say while not game over, you continue to run the game, basically, right? So maybe you're playing like Pac-Man or like you're playing Flappy Bird, right? So the condition that game is over in Flappy Bird is that you hit a tube, right? Your bird hits a tube. So before you even hit a tube, before you hit a tube, the game is not over, right? So this is true. This is true as long as you don't hit any tubes, and so you keep the game running. Now, if you do hit the tube, then this becomes false. So game is over. Then you stop running the game and you stop this while loop going. So this is kind of the idea of while loops. And most of the time if you find yourself thinking or saying to yourself, okay, I want to do this until some condition is satisfied, then you're likely going to see yourself using a while loop. Now, we're going to try something. So what we're going to do is open up our project, which is turtle while. Now, if you don't have that open, you should be able to open zip jar and then open up the turtle while zip jar. I have mine open, so I can just open that. So in here, you should be able to see this world and turtle. So what we're going to do is we're going to try to draw a square again. So we're always trying to draw squares. And let's just type that in, okay? So um, let's go ahead and say our turtle dot forward t, and then you could turn either left or right. Doesn't really matter. I'm gonna copy this 4 times. Okay, so this is how you draw a square. And it's nice to just comment so that you know that this is for drawing a square. Okay, so now we know how to draw a square. Can we actually use a while loop to, you know, can we use a while loop to optimize this, to somehow make this into a more concise uh, set of lines? So let's think about this a little bit. Let me go down here. So in while loops, what we said is what we say is while a condition is not while a condition is satisfied, you run that loop, right? So while some condition is true, then you repeat whatever is inside here, okay? So just like any other loops, like other for each or for loops, here is sort of like your body. Here is the body of your loop, and the while loop is going to execute whatever is inside the body. So it might be a few lines or one line, however many lines, it's just going to go ahead and execute those lines at once and then come back to check if the condition is true. Okay, so that may be a little abstract. So let's think about how we can draw a square. Just not thinking about while loops yet. Let's see how we usually draw a square. So, for me personally, what I could do, right, is say, okay, I know I'm going to draw 4 sides, right? So before I complete drawing 4 sides, I'm going to continue to draw the sides, okay? So I can think about that, right? And I basically say, okay, I'm going to do this. Okay, so I've drawn one side, and now I'm going to draw the second side, and then draw the third side, and then draw the fourth side. Okay, so I've drawn 4 sides, and now my square is complete, right? So this is your first side, this is your second side, third side, and fourth side. Okay, so now how can we think about drawing the square in the context of a while loop? So what we would say, right, is to say, okay, well, while, I basically don't have 4 sides drawn. Oh, geez. Okay. Well, I don't have 4 sides drawn. I draw each side, right? So what does drawing one side look like for a square? Well, we know how to do that, right? We move a turtle forward, and then we turn it to the right or left, whichever. Okay. So now this thing is interesting. How do we know if we've drawn 4 sides? Is there a way that we've learned that where we can keep track of how many sides that we've drawn? Think about that for a little bit. Okay, so the way we can keep track of this is through a use of variables. So we can use a variable to store how many sides we've drawn. Okay, so what does this look like in code? So let's go over here. Okay, so we know that here we've drawn, we'll be drawing one side. So one side, 2 sides, 3 sides, and 4 sides. Okay, so here we've drawn 1 side, 2 sides, 3 sides, 4 sides. And now let's work up to the while loop. So what I'm going to do is I'm going to create a variable called sides, and it's going to hold an integer, right? Because however many sides, there aren't really like a decimal number. Like I can't have 2.2 sides. I guess you could, but it doesn't really make sense in in this uh, in this context. So I'm gonna say um, 0 for now. Okay, and because at the start we haven't actually drawn any sides, right? Okay, so now what we could do here, after we've drawn one side, then we can say, okay, sides is 1. So now we've drawn one side. Okay, let me put that semicolon there. How about here? What side's going to be here? 2, right? Because now we've drawn two sides by this um, by this line. So we've drawn two sides. Okay, and then the same thing is here. So we can have sides is 3, and now sides is 4. Okay, so um, now we've kept track of how many sides we've drawn with a variable. Okay, and now how is there a way to sort of generalize these numbers? Because I see something that is repeatable. For example, these two lines repeat, and these lines don't really have a repeatable uh, aspect to it. It's just like I actually need to put the number 1 and the number 2 and the number 3 and the number 4. Is there a way that we can keep these lines the same, but they do the same thing? So is there a way to sort of, in other words, increment the variable so that I can keep these lines all consistent and repeatable? The answer is yes. Okay, so um, usually what what we can do is we can increment. So for example, I could say sides is set to sides plus 1. Okay, so remember that to the right side of the equal side, this expression is executed first. Right, so what is sides right now? Right here. That's 0, right? So sides is 0. 0 plus 1 is 1. And now 1 is going to get assigned to 2. Okay, let me put some comments here. Okay, and let me comment all these out just so we can reference it. Now, can we copy this line over down here? What will that do? Right? Okay, so this might look a bit cryptic and hard to decode, but let's break that down. So what is size right here? What is this side or size variable? What is the value of this? Well, the value of this comes from what gets assigned up here. So what was assigned up here? Well, from here we know we have 0 plus 1, which makes size 1 at this point, which is consistent with this. And now, so here, sides is still 1. So 1 plus 1 is 2, right? And 2 gets assigned to sides here, which is consistent with what we said here. Okay? And now, if we do the same thing down here, sides, remember, sides gets assigned to 2. So that means 2 is going to be here. So 2 plus 1 is going to be 3, and 3 gets assigned to sides again. Okay? And lastly, sides is 3 plus 1, and so 4 gets assigned to sides here. And we can verify this, right? So what I'm going to do is I'm going to type system.out.println sides, okay? And now I'm going to print out sides here, okay? And to make things a little easier on our eyes, the first side. So I should be seeing, the first side I should be seeing 1. The second side I should be seeing 2. the third side I should be seeing 3, and the fourth side I should be seeing 4. Okay, so if this all makes sense, let's compile this. So let's compile this and hit void main, run that. Okay, so we've completed drawing a square, and let's see what it says over here. Okay, so let me pull the terminal window open again. All right, so we see the first side is 1, second side is 2, third side is 3, and fourth side is 4, which is exactly what we want, right? Sides gets assigned to 1 here, sides gets assigned to 2 and 3 and 4 and so on and so forth. Okay, so this is how we can increment the same variable over time. And this is the syntax. Okay, so basically this says, okay, I'm gonna just increase sides by 1 every time I call this line. I write this line. Okay, so now that we have something that is repeatable, we have basically, and I'm gonna get rid of this if you will excuse me, because now it's just less clutter. So now we have 3 lines that are repeatable, right? All these lines are exactly the same, and we can repeat these, okay? So here's what I'm going to do. What I'm going to do is I'm going to say a while loop, and I don't know the condition yet. Maybe let's not think about the condition, but what we do know is I want, actually let me copy this, okay? Copy and paste, and then let me indent these two so it's readable. So I want to keep executing these 3 lines how many times? I want to execute these 3 lines 4 times, okay? And, you know, what does that mean for our expression or our condition here? So while what is true, we should keep drawing aside. Okay, so that sounds a bit convoluted, but what do we say over here? We said, while we don't have 4 sides drawn, we keep drawing aside, right? So that means while the number of sides that we've drawn is not yet 4, then we keep drawing, okay? So that means we can directly just say, while sides is less than 4, okay? How does this make sense? And actually, let's verify this. And I'm going to comment out all these lines down here. And then I'm going to go ahead and compile this, run this, and it does indeed draw a square. So how did this work out, right? How did this work out? Well, so first we know that sides is 0, right? And actually, let me see if I can do this. So let me pull up the whiteboard also. But what we can do now is we can sort of trace through this program at the same time. So what I'm going to say is, okay, so I'm going to have at least, let me think. So, okay, so I'm going to have one side that is a variable. Okay, and I'm going to draw a few more lines over here, a few more columns over here. And these are going to stand for the number of times that the while loop executes. And so the number of times the while loop runs these lines. So the first time the while loop runs, second time the while loop runs, third time, and fourth time. Okay, so we know that sides. So let's just keep track of sides. The sides variable, the first time it gets executed, right? The first time this while gets executed, it first checks if sides is less than 4. And right now, sides is 0, right? So to begin with, sides is 0. So sides 0, that means 0 is less than 4, right? That means yes, we execute these lines. Okay, so it draws a side, and we say, okay, draws one side. And now, remember the turtle has turned left. So I should probably move it over here. Actually, move it down here. Okay, and now sides is assigned to sides plus 1. So 0 plus 1 is 1. So we have sides is now 1. Okay, now in the second time the while loop runs, sides is now 1. And 1 is still less than 4. Okay, so that means we execute these lines and we say, all right, t goes forward. Okay, and now it's going to turn left again, and sides is now going to be 1 plus 1, which is 2. Okay, and now it's going to go back up here, and it's going to check if sides, which is 2, is less than 4. And that is true, right? So we go ahead and have the turtle move forward and turn left. And now we want to get assign sides back to sides plus 1, which is 2 plus 1. So that means sides is now 3. Okay. And now we go back up here. We say, all right, is sides less than 4? Yes. Right. So yes. And now we're going to complete this drawing over here. And since we want sides plus 1, 3 plus 1 is 4. So in the fourth iteration, sides is going to be 4. Okay. And now it's actually going to go back up to this condition up here. So sides is less than 4. What is sides? Sides is 4. Is 4 less than 4? No, right? So we stop that loop right there, and then we jump out of the loop. We stop executing in here because this condition is no longer true, okay? So this is how we trace through the program, and I think in the next video, I'll show the debugger, which will be helpful for our sort of mental model.